So today we are going to talk about a very important topic in Apex, which is asynchronous Apex. So asynchronous Apex is basically about executing Apex code asynchronously, or I would say independently in the background. So it's slightly different as compared to the other Apex code that we execute, right? So what is asynchronous Apex? As I said, this is the code, Apex code, still a piece of Apex code that runs in the background, and it runs independently, so it does not immediately require a user to initiate the code, etc. So there are different ways of executing asynchronous Apex, and it is something which is capable of starting to execute on its own independently and in the background. So there is no immediate user interaction required, and the purpose of this is basically to get executed when the system resources are available. All right, so now we may be thinking that, okay, fine, why do we need something like this which needs to execute in the background or independently, etc. So let's understand it this way. So there can be two types of Apex code or Apex logics that you have written. There can be two types of logics. So first can be a logic which needs to get executed immediately. For example, a validation rule. So if you're trying to validate a record, when a user is creating the record, if you're trying to validate the record, the validation needs to happen immediately. So if I'm trying to create a record right now, I need the validation to get executed immediately, right? So that is something which needs to get executed the moment that user is interacting with the system, etc., right? But every logic does not need to get executed immediately along with the user interaction. So I'll give you another example. Let's say you have an Apex code or a logic written which would check for some 3-4 fields and either automatically populate the values for those fields, or it will possibly go and clean up some of those fields, right? Now, the requirement for these 3 or 4 fields, let's say it is only meant for a report which is generated once in a month, right? So these kind of logics are not necessarily required to be executed the moment user is interacting with the system. Now, if you try to execute all the logics immediately when the user is still interacting with the system, the problem is that your system will start failing more frequently because it is doing a lot of stuff, in real time. Okay, so just to ensure that your Apex code does not interrupt other important logics, etc., there is this concept of asynchronous Apex. Even let me make it even more simpler for you. Let me give you another example which you would be immediately able to relate to, and then you will be able to understand why there is a need of asynchronous Apex. So think of it like a scenario. Let's say you are sitting in office and you get a call, right? So sometimes what happens, we see the call and we realize that, okay, this call is important and needs to be answered immediately, right? Some calls are like that. There are a few calls. Let's say I'm getting a call from a friend and I have to do a long conversation with that friend. I realize that, oh, maybe this is not the right time. I will possibly call my friend later in the evening, right? So that is asynchronous. That is kind of an asynchronous concept, right? So the calls which you immediately need to answer because those may be important, that's synchronous. And the calls where you decide that, okay, fine, let me just text my friend, okay, I'll call you back in the evening, because the conversation is going to be slightly longer, you need a little more extra time, and it's not something which is urgent, right? So the same way, you cannot be answering all the calls right in the office, because then it will start interrupting your work, right? So same logic applies there. So if we cannot say that if there are 100 logics which are getting executed, we cannot put all the 100 logics to be executed immediately, instantly along with the user interaction, because then it will start impacting the overall performance of the system. It will start interfering with the important logics, right? So you will have to or let me not say important, let me call it as urgent. So if you have to execute 100 logics, yes, you need to execute all 100 logics. Do you need to execute all 100 logics synchronously, immediately, instantly as the user is interacting with the system? The answer to that is possibly no, right? So whatever can be executed with a little bit of delay, those should be executed as part of asynchronous Apex. All right, so that is the thing. So this is primarily used for long running operations, bigger operations, things which are not that important, cleansing sort of activity, update sort of activity, those can be executed as part of asynchronous Apex. Now, let's quickly understand the types of asynchronous Apex. There are 4 types of asynchronous Apex. So which would mean basically you can execute or invoke Apex code asynchronously in 4 different ways. The first one is a future method, then we have a Queueable Apex, then we have a Schedulable Apex, and then we have batch Apex. So these are the 4 different types of asynchronous Apex which are permitted or allowed within Salesforce. So let us begin with understanding each of them. So future methods. Future method is the most simplest form of asynchronous Apex. Now what it is simply a method similar to other methods that we have in Apex. The only difference between a future method and a normal method is that future method can be executed in future. As the name suggests, future method, it is a method which will get executed in future. Now what does future mean? Future means it will get executed when the system resources are available, right? So synchronous Apex, what will happen if the system resources are not available and you have just defined a method? The method tries to get executed, and if it finds the system resources are not available, if it is not able to get executed, it would fail, right? But with the future method, what happens? It waits in the queue, and when the system resources become available, then it gets executed, which is the good thing about a future method. So if you are thinking of executing a long running operation, you may use a future method. So the advantage that you will have is, one, it will not interrupt or interfere in the execution of the synchronous Apex. So whatever is your most important logic which needs to get executed first, it will wait for the future method will wait for its turn. It will wait for the system resources to become available. It is not going to interfere with the other synchronous logics. It will allow synchronous logic to get executed first, and once the synchronous Apex has got executed, then this will go and get executed. So it waits in the job queue and it gets executed only when the system resources become available. So that future, when we say future, does not mean like after 10 days or after 1 year or something like that. It only means the future can be after 2 minutes, it can be after 1 minute, at times, and it can be instantly also at times. If nothing else is getting executed, this method can get executed instantly also. But if there is something else that is getting executed, system resources are not available, then it will wait for the system resources to become available and then it will get executed. So that is about the future method. Now, a few key things about future method. So first of all, yeah, it is used for executing long running operations. That's something which we understand. Secondly, if we talk about this as an example, you can think of a call out to an external web service. So if you're making a call out to an external web service and which is going to be a long running stuff, then you can possibly use future method. These operations run on its own thread on its own time. So as I said, it will wait in the job queue. It will run on its own thread on its own time when the system resources become available. So there is no hurry for this method to get executed immediately. These are queued and execute when system resources are available. So this is what we have discussed. Waits for system resources to become available, and when the system resources are available, then it gets executed. Advantage of it. So why would we do this? So the biggest advantage of this is, there are two things. So one, of course, this way you are not putting additional pressure, or you are not putting additional performance related stuff into your Apex engine. So your code, the most important code gets executed. Those are not interrupted. So you are clearly bifurcating between this code is more important for me, this code is slightly lesser important, can be executed after some point of time, right? So now, advantage of a future method is that or asynchronous Apex in general, usually asynchronous Apex get comparatively higher governor limits. So in Apex, everything is controlled by governor limits. For everything, there is a governor limit which is defined by Salesforce. Comparatively, the governor limits for asynchronous Apex are higher for some of the governor limits, not for all, but for some of the governor limits, like SOQL queries limits, your heap size, etc., will get slightly higher governor limits. I'll talk about this a little bit more in details, but later on. Now let's go a little further and talk about the syntax of future method. Syntax of future method is very, very simple. So there is no specific syntax as such, but there are a few things which you need to understand. So from a syntax perspective, all that you have to do is, if you just need to define a method as a future method, you simply need to use add future annotation here. Okay. So for future methods, all that we have to do, we just have to use an add future annotation before defining the method. So if this is your method, right, what you'll do before the method, you will just go and put add future annotation. So what will this add future annotation do? This add future annotation is going to indicate that this is a future method and the code will get executed. Then the property of this method will slightly change now. It will wait in the job queue. It will not get executed immediately, and it will wait in the job queue for the system resources to become available. When the system resources are available, then this method will go and get executed. All right. So now, as I said, the syntax part of this is pretty simple, straightforward. However, there are a few things that we need to keep in mind while we are defining a future method. First thing, your future method is always a static method. It has to be a static method. It cannot be otherwise, right? So it is always required to be a static method, and it can only return a void type. So it cannot return a value. This method always has to return a void type. Now, primarily the reason for that is if the method is basically returning something, some other value, and that value is being used by some other method, then your entire flow will not work. So all asynchronous Apex need to be void type. So for any method where there is another piece of code or another user who is waiting for a return value, those cannot be defined as your asynchronous Apex, right? So for example, if I write a method and this method has to retrieve some data and it has to show the data to me on the user interface. Now this cannot be an asynchronous Apex, right? Because there is a user waiting for the return value, right? So these methods ideally, they get executed, but they would not return anything. So that type of method only should be asynchronous Apex. So for your future method also, it always has to be, it always has to have a return type void. So that is another part. The specified parameters, in case in the method, if you're defining parameters, you cannot have those parameters, or those parameters can only be primitives. Those can be primitives, arrays of primitives, or list of primitives, collections of primitives. These are permitted. Okay. Now, what is not permitted? S objects are not permitted as parameters, or objects are not permitted as parameters. You cannot specify an S object or a collection of S object as a parameter for future method. Now, the reason for that is very, very simple. The reason for that is because your S object is basically a live record. So if I try to specify an account A1 as a parameter, now the issue with this is that this A1 is a live record, right? Now, if A1 is a live record, it can change from time to time. So let's say my future method got called at 9:10 a.m. and it actually got executed at 9:40 a.m. There is a possibility that the value in the A1 can change between these two times, right? Between 9:10 when it was actually called versus 9:40 when it got actually executed, right? Now, what will happen here? Your record will still work with the old value and it will override the new value. So at 9:40 when it gets executed, it will override the new value. At this point of time, the values have changed. There's a new record, but it is still working with the old value, and this overrides the new value. So that becomes an issue. That causes inconsistency in your database, and that is the reason why you cannot have S object as parameters. Now you may be thinking, okay, fine, if this is the problem, what is the solution to this? We'll come to the solution of it, but with future method, you do not have a solution to this. All right. There is a workaround, which again I will discuss a little later, but this is what is permitted within your future method. So you always have to work with primitives as data types, all right, and collections of primitives. Even if you have to work with a record, you can use ID. There is a data type ID which is also of primitive type. You can use ID of the record because IDs will not change, and then you can query the ID inside the method and then you can execute it. But as parameters, you cannot use S object data type as parameter for your future methods. Okay, and that's what we just discussed, that it cannot take S object or objects as arguments for these two reasons, because the values might change between the time method was called and the time when it was executed, and if that happens, it is going to override the new value with the old value which it has taken when the method was called. Okay, so now another aspect of the future method. So future method can also be, so we spoke about where the future method can be used. So let's talk about a few more scenarios where future methods can become very useful or helpful. So future method, one of the I would say practical use cases of future method is also to work with mixed DML operations. Now, what is mixed DML operation? Mixed DML operation is primarily when you are trying to do two DML operations in the same transaction with two types of objects. I'm going to come to that. So Future method would let you isolate your DML operations. Future methods will let you isolate your DML operations, right? So isolating DML operation means, if, as I said, if we are trying to perform, if this is my code, and if I'm trying to perform, let's say DML1 and DML2, okay, then let's say if I want to create a user and then I want to create a custom record in a custom object. Let's say DML1 is create a user, DML2 is create a custom record, and if I'm trying to do these two things in the same Apex code, same method, then what happens usually, Salesforce throws a mixed DML error. All right, so the mixed DML error basically occurs when we try to perform DML operation simultaneously on two objects, two types of objects. So one object can be a standard or custom object. So when you're trying to perform a DML on a standard or a custom object along with a system object, so these are two different types of objects that we have. We have the standard or the custom object, right? And then we have some certain system objects. System objects are the objects like your users, user role, group, profile, etc. So these are system objects. So if you're trying to perform a DML on both the types of object at the same time, then Apex throws a mixed DML error, right? So what would happen? So in this example, I'm trying to do two DML. So my first DML is on the user object, which is a system object. And the second one is a custom record on a custom object, right? Now what will happen in this case? It would throw a mixed DML error. Future method can be used to isolate these two things. So, then what would happen? Then you would not encounter this particular issue, right? So this is a very, very practical use case of future method. The next thing that we will discuss is about the Queueable Apex, right? So we have seen future method. Future method, as I said, is the most basic form of asynchronous Apex. Slightly advanced as compared to future method is Queueable Apex. Now, Queueable Apex is, it does pretty much what a future method does, but in an enhanced way. So it is, if I say that Queueable Apex is an enhanced version of future method, it may not be wrong. So initially, Salesforce had future method, and then they introduced Queueable Apex, right? And Queueable Apex, in fact, as I said, does the same thing. So core purpose can be similar or same, but in addition to what a future method does, Queueable Apex has got a few more attributes which are helpful or handy, where for you to work with different scenarios, or in different kind of with different kind of requirements, etc. Right? So how does this work? So Queueable Apex actually works with an interface which is called Queueable interface. So already we have an interface called Queueable interface. So when you're writing a Queueable Apex, you use that interface. So you implement that Queueable interface, right, for your Queueable Apex. Now with the Queueable interface, so there is this interface called Queueable interface, which is implemented on Queueable Apex. Now what does this do? This interface enables you to add jobs to the queue and monitor them. So what is basically the core functionality of this interface? This interface allows you to add job to the job queue, and it also allows you to monitor the job. So basically, eventually, a code which implements this interface can be queued, can be put into the job queue, and putting it into the job queue ideally means it will be in the queue, it will wait for the system resources to become available, and once the system resources are available, then it will get executed. Correct? Now, this is the key thing. In a way, this is an enhanced way of running asynchronous Apex compared to your future method. So pretty much the same stuff it is doing, but in a slightly more advanced or enhanced way. So your long running Apex code can be queued by implementing the Queueable interface. So if you have an Apex code and if you are implementing the Queueable interface, you will have the ability to queue the Apex code, and it also has the ability to be added to the Apex job queue. All right. Now, We will have a quick look at the syntax for this. Okay, the syntax for Queueable Apex is slightly different, okay, as compared to future method. So future method was just a method, and all that you had to do, you had to simply use the add future annotation before that method. In Queueable Apex, you define it as a class because you'll have to implement the Queueable interface. So you define it as a class, and the syntax is like this. So you define a class, you can just name your class whatever you want. I've named it like this. You'll have to implement the Queueable interface. Let me use some other color, maybe. Yeah. You'll have to implement the Queueable interface, right? And inside that class, you just need to define one method, which will be a void method. So you define one void method. This is the method. It's a void method. And name of this method has to be execute. Okay, so this is how it works, right? So this is going to be your syntax. So you define the method inside a class. That class should implement Queueable interface. And the name of the method has to be execute, and it has to be a void method. And then your code logic can come here. So whatever code block you have, I've just put a sample code here, but whatever code you want to execute, that code can be put here. Okay, so now how are you defining a Queueable Apex? You define a class, you implement the Queueable interface. Inside that class, you define a method which has to be a void method, and the name of the method has to be execute. Inside that method, you go and define your code block, whatever you want to execute. All right. Now, once you have written the code, the next point is how would you put the code into the job queue? For future method, it was slightly different. It was a method, so the method can be called. Now, for this particular Queueable Apex, since it's written inside a class, you have to put this code into the job queue, right? So we are not calling the method directly. So what we are doing, we are basically putting this Queueable Apex into the job queue. So as I said, the advantage of using Queueable interface is that it lets you put your Apex code into the job queue. And how do we do that? So we do that using this predefined function, which is system.enqueueJob. Okay, and here you will put the name of your Queueable interface, Queueable class, Apex class, right? So that is the thing. So this is a predefined method, system.enqueueJob. This is used for putting an Queueable Apex into the job queue, right? So once you call this, once you call this function, it will put our asynchronous Apex example or whatever your Queueable Apex class into the job queue, and it will again behave pretty much the same way a future method would have behaved. It will wait in the job queue for system resources to become available, and once the system resources are available, it will get executed. All right. So there is no again particular time for it. It can get executed in 2 minutes. It can get executed in 30 minutes, depending on how busy your overall Apex execution is, on your system. Right now, the advantage of using Queueable Apex is that once you put this, it returns a job ID which is of type ID. Okay, so each job which is put in the job queue will have a unique job ID. And now this job ID can be used for monitoring the progress of the job. That was not the case with a future method. So for future method, we did not have a job ID sort of a concept. For that reason, it was not possible for us to, retrieve the status or the progress of that particular operation. However, with Queueable Apex, this is an advantage. You get the job ID. So like here, we have retrieved the job ID. Now, what we can do, we can query the information about this operation using the job ID. And for that, we just have to write a query. So we can write a SOQL query on this object. So there is this object async apex job. So async apex job is the object which contains complete list of all the apex jobs which are running, right? So all that you have to do, you simply have to write a query using the job ID. So if you see on this particular object, async apex job object, you can write the query and you will be able to retrieve the information, right? So the advantage that we are getting, the big advantage that we are getting with Queueable Apex, we are getting a job ID, a unique job ID, which helps us monitor or track the progress of the Queueable Apex, right? Or the the actual asynchronous Apex code which was getting executed, all right? So that is the thing. Now, the next thing that we are going to talk about is future versus Queueable. Since I spoke about it, since I discussed about Queueable Apex being an enhanced version or enhanced way of executing asynchronous Apex as compared to future method, then it would be good for us to quickly compare future versus Queueable and understand what are the key differences. Okay, so before I talk about differences, let's quickly talk about similarities. So first similarity, or the most important similarity, of course, that we have here is both are queued for execution. Okay, both are asynchronous Apex, both will get queued for execution, both will wait for system resources to become available, both will get executed when the system resources become available. So that is the key similarity between both the operations, right? Now, coming to the differences. Now, what are the differences? So in terms of differences, there are three key differences. First key difference is the job ID. Queueable Apex provides you with a job ID, a unique job ID, which can be used for monitoring the progress. So as we discussed earlier, Queueable Apex will always, the moment you are putting a Queueable Apex into the Apex job queue, it will create a record, and record will have an ID. So that ways, it will always have a unique ID, and you can always go and check the status using that particular ID. So that makes things easier, simpler. So in case you want to execute some other logic and you want to quickly track only if this gets executed, then go and execute the other logic, then it becomes easier for you. So that sort of thing, right? So monitoring, tracking is better with Queueable Apex, right? Second big difference is the use of non-primitive data types as your parameter. So what we discussed in our future method was we could not specify parameters other than primitive data types. So we could not specify SObjects as parameters, right? We had to work with a workaround of supplying ID, or we had to work with primitives, right? There was no way for us to specify SObjects as parameters. That's not a restriction with Queueable Apex. The reason, so Queueable Apex can work with non-primitive data types as well, which means it can work with SObjects also as parameters. Okay. So the reason for this is a class. So even if you have used parameters inside the class, there is method, and if you have used the parameters, the class waits in the job queue. When the Apex code is actually getting executed, at that point of time, it will run the query and it will retrieve the value. Not like comparatively for future method, it was slightly different. It was a method, and if you defined a parameter, it would pick the parameter values and then gets into the job queue. Here, it is not happening like that. In case of Queueable Apex, it would, when the system resources are available, when the execution is about to happen, at that point of time, it is going to run the query, get the latest value of the record, and then work on that particular record. And that is the reason why the challenge of using only primitives as primitive data types as parameters does not apply here, and you are free to use other non-primitive data types as well, like SObjects. Okay. And the third difference is about chaining of jobs. So usually with Queueable Apex, you have the option of chaining of jobs. So you can basically execute one method, and from inside one method towards the end of that method, what you can do, you can define or call another Queueable Apex. So that ways, if you have three Queueable Apex, so let's say I have three asynchronous jobs to be executed, A1, A2, A3. Let's say this is what I am planning to do, right? So what I can do, I can have my code for A1, and from here I will call A2, and then when I have the code for A2, there I'll call A3. Okay, so that way it is going to be a chaining of jobs. So you just put A1 into the job queue using system.enqueueJob, call A2 from A1 towards the end of it when the entire thing has got executed, and again do the same thing. So that way you will be automatically able to control the sequence, or you will be able to chain multiple jobs, so which was not again available with your future method. So these are the key differences, and this kind of shows how Queueable Apex are more capable as compared to future methods.